Assalamualaikum warahmatullahi taala wabarakatuh. So today we have looked at HVAC solution software last week, and for this week, I'm gonna introduce you some overview on general HVAC system so that you can what we call start designing your system in the HVAC solution. So we just gonna refresh a bit. What is HVAC system? And yeah, so then we will gonna look at several components in the HVAC solution software. Right. So last week I've introduced you air handler unit or air handling unit AHU. So just gonna refresh again. AHU is used to condition and circulate air as part of an HVAC system. How? By cooling, by using cooling coil, or heating by using heating coil, filtering all the particulates accordingly, and of course to cool the air. And basically AHU contains blower, heating or cooling elements, filter, and sound attenuators to dampen the unnecessary noise. All right, so this AHU connects to ductwork that distributes the conditioned air through the building and returns it to the AHU. Right. AHU maybe need to supply heating, cooling, or both. And a furnace will be used to generate heat, and this furnace may use fuel oil or natural gas as a fuel source, or heating elements by using electric, or heat pump. And a refrigeration system, whereas a refrigeration system absorbs heat. For example, air conditioner absorbs heat from space, or heat pump to pump heat into space so that the space will be heated as required. And smaller air handlers may contain a fuel burning heater or refrigeration evaporator placed directly in the airstream. But large commercial air handling units contain coils that circulates water, and boiler will provide hot water or steam, and the chiller will provide the chill water. Okay, typical AHU components. We have normally in here we have supply duct to supply the air. We have fan compartment to locate so that we can position the fan, the necessary fan. Then we have flexible connection in between this one. And number 4 is a heating or cooling coil in here. Number 5 is a filter compartment. And number 6, this one is return and fresh air duct. So just please bear in mind how it is arranged. In the AHU cabinet. In HVAC solution, as I mentioned in the previous lecture, there are two ways to design a air handler unit. One is by using the air handler icon, and you need to pull all the components out from the taskbar. And second one is by using wizard icon. By answering several questions, and then the system will be created automatically. Right, so I'm going to show you once more how to build an air handler. As I said before, we have two ways how to build an air handler in HVAC solution. Okay, the first one is by using air handler icon. Okay, this time I show you an example complete with the figures, and it's a closed cycle because we have space here. Right, so I'm going to show you how to do it. Okay, let's see. Right, how to do it in HVAC solution. Okay, first you just go to air handler tab and select air handler cabinet and add in the numbers of plenum that you need. In this case it is 4. Just add 4 plenums. Alright, so next we have a filter of MERV 4. So I'm gonna choose cartridge type. Just put in the first plenum. Right, so don't forget that the airflow schematic will also appear, so you just put the filter aside first. Alright, so next we would need a heating coil. So I'm going to choose hydronic heating. Let's put in the second plenum, put the flow diagram and also the hydronic diagram put aside first. And the third one is the cooling coil from hydronic cooling coil. Just click on it and put it inside the plenum. Right. Okay, and the last one we would have supply fan, but the plenum is now shifted. So I'm just gonna add one more plenum here. And this one you can just right click and delete. Right, so just go to fan, supply fan, no supply fan, no manufacturer. Right, so I'm gonna choose forward curve centrifugal, and of course you're gonna have to choose the needed supply fan according to the requirements of the project. And as for now, we do not need a hydronic schematic diagram, so I'm just gonna delete this one first. And the last one, to complete the cycle, we would need a space. So just click on the space tab, and on your left you can choose numbers of space type. We have office, light commercial, school, hospital, apartment, industrial plant, etc. So I'm going to choose office. Okay, so I'm going to put here. And now I will connect everything into out, into out. right? It's a bit lag. Okay, now if you move on the diagram, you could see this one is exhaust air out, supply air in, and this one is return air out. So you connect supply fan to supply air in. Now connect the return air out. We assume that we will use 100% return air, so just connect it again to the filter. Right, so everything is in color now. That means the connection is correct. Okay, so what we have to do now is actually just go back to the diagram and see what is the what we call the condition of the space. Now we can see that in purple color it is written that it is the space has 72 degree Fahrenheit and 50% of relative humidity. That means during cooling and also heating season, for both seasons, we will have this temperature and this relative humidity. So just go back to the space and double click. Sorry, before that, the setting now is, it's quite unclear. It's a bit unclear. I cannot maximize. It's already maximized, but yeah, now it's a bit bigger. Oops. If I can put the workspace, bigger workspace. This one is project 2, right? Right, you can actually zoom your workspace and move with this hand icon, maybe to the middle. You can zoom it more so that you can see the figures. Okay, so now it's a bit clearer, right? Okay, I think it's good. All right. Okay, so we can see now that the condition is already correct. It's 72 and okay, just change to select icon so that you can double click on this. Okay, so now we have the data space air conditions. Okay, now we have for both heating and cooling seasons 72 degree Fahrenheit for dry bulb temperature and 50% of relative humidity. Right, so it's already all right. So just leave it as it be. Now we see the supply air. Okay, for the red one, 25,000 CFM means in heating season, the fan will supply 25,000 CFM, and for cooling season, this fan will supply 35,000 CFM with a static pressure 1.6 inch water gauge. All right, so just set that first. Okay, so now just double click on the space again, because actually all the inputs is according to the load, according to the load. So the load now in this case, in our case, is the space. So now we just double click on this again, and okay, we try to find CFM is the airflow, right? Here you can set for heating season. Just now we have 25,000 CFM, and for cooling season we would have 35,000. Or is it the way around? No, it's correct. Right, so just click apply. Okay. Yeah, now it is shown here 25,000 and 35,000, and the static pressure is already correct. It's 1.6. And now we can see the input to the heating coil is 72, the inlet temperature, and the outlet is 85 degree Fahrenheit, and 74 for cooling coil degree Fahrenheit for cooling coil, and 50.8 degree Fahrenheit for cooling coil. Okay, actually the settings is also on the space, so just go back to the space and click on supply heating air condition. Okay, this one is for setting the temperature of heating coil. Okay, as you can see here, the minimum dry bulb temperature means what is the temperature after the heating coil. So here I set 85, and for cooling season you can actually put 0 because this is a setting for heating coil. All right, so click apply, click OK. Right, and do that once more. Double click on the space to set the supply cooling air conditions, and for this time for heating season we set it to 0, and for cooling season we just set here target supply condition. If you do not know it, then just read the explanation below. Target supply conditions for cooling air supplied to the space are calculated based on space condition during cooling season. And second one, the cooling dry bulb temperature entered above. Right, so the target supply conditions may differ somewhat from duct conditions due to lack of components required to create the specified space humidity level. Other means exist for this condition is to occur, such as space-based latent gain. Under that is occupant load, infiltration effects, etc. And the user should be familiar with the air condition cycle required to maintain space condition as specified in the space air tab. So as you can see here, the dry bulb temperature is set to 52, and the sensible heat ratio is set to 0.9. So we will have more or less, click apply, just click apply, click OK. So we have the outlet temperature of cooling coil is 50.8 degree Fahrenheit. It's more or less near to the example. An example, we have 50.9 degree Fahrenheit. Why do I show you all these settings? Is because I want you to answer these questions. All right. I'm not gonna answer for you, so I hope you can try. Okay, first one, when the area of ducting is reduced, does that affect velocity? And when length of duct is increased, what will happen to the pressure? When flow rate is reduced, what will happen to velocity? If room size is adjusted, what will happen to supplied air? Where does all these settings can be altered? Yeah, you can see here. It's a bit lag, so I hope you can bear with me. For the space size, you can actually alter it. Wait a minute. There's dimension. Yeah, this is the dimension. So just double click on the space, and under selection, we have dimensions. And this dimension is the space dimension. Let's say here we put, for now we put 8 times 8 times 8. The length and the width, and length times width and times length is 8 times 8 times 8 equals to 64 feet square. Or the volume is 512. So if you want to change a space size, change there and then answer the questions. All right. Next one is the duct length or duct area. Okay, for the duct length, you can actually click on the duct and right click. Can put duct annotation and size. Now the size is 74 over 74 feet. Inch. Yeah, if you want to change, then you can change it here. Just tick the box and change the size of the duct. And the length can also be changed here. For example, we have 10 feet. All right. So I need you to do this for me. Not for me, it's for you. So just change the thing, the thing listed here, and see what happened to the parameter that is asked. What happened to the velocity? What happened to the pressure? What happened if flow rate is reduced? Flow rate is CFM. So again, just change it. Click on the space. All right, so click on the airflow. So if the CFM is changed, the airflow is changed, what happened? What happened to the velocity? All right. So I believe you can do that. Okay, next. I'm gonna leave this. You can try it later if you want. If you add written air fan and also terminal duct unit. But we're gonna see it later. Now I want to show you if you use Wizard. to design your AHU. Right, so these are the questions that may be asked by the software, and you need to put the answer. Number of systems is 1, which means you have one air handler. Detail level, system space zone. Cabinet type, air handler. Usage is for cooling. Please include terminal duct and single duct. Usage and medium for reheat and hydronic. Draw through fan. Please untick the relief air and return fans. We do not need relief air and return fans. And type of pre-filter is cartridge. If you do not remember, you can always come back here. All right. We still have several conditions here. All right. So just answer the first few questions first. All right. So just go back to your workspace. Click once more. New. All right. Here is the tab for new. Now you have new. Now use wizard for air handler wizard. Right, so number of systems is 1, right? Detail level system space zone. Let's put system. Next, cabinet type air handler, cool. Cabinet type air handler, ID you can just put 1 or 2. This is just for identification of your AHU. For example, if you have 3 air handler for the building, then you would need ID 1, 2, and 3 so that you know. Right, cabinet type air handler, usage for cooling only. Use data for reminder systems. Why not? Next. Right, include terminal. Right, terminal duct include single duct. Terminal unit, single duct. And usage and medium, reheat and hydronic. Okay, just click on next. Reheat and hydronic. All right, it's already default. Click on next. We use draw through fan. Let's untick relief air and return fans. We use draw through fan. And preferred manufacturer, yeah, depends. Choose none. I would love to use, for example, just use as an example, I use forward curve centrifugal. Right, click on next. Okay, include return relief fans. Yeah, untick this one. Relief air, exclude. Okay, exclude. Right, so next, what does it say? Type of pre-filter is cartridge, right? So it's cartridge. Okay, just use MUF 8. All right, just let it be. Okay, just look at the next slide. We have no sound trap. Input supply airflow is 35 CFM. Length, width, and height of AHU cabinet is 183, 84, and 8 feet. Number of peoples, 20. Source of cooling is water-cooled chiller and cooling tower. And yes, you can change the type of space by double-click on the space. No sound trap. No sound traps do not include. Written sound do not include. Right, cooling, cool medium. cooling coil medium, water cooled chiller and cooling tower. Yeah, just put hydronic. Next, this is space, right? Yeah, space. And the supply airflow, I did just put, if you have different space, for example, 5 spaces to be served by one AHU, then you need to put ID, 1, 2, 3, 4, 5. So just put location just for your information. Let's say zone 1, just put zone 1. All right, the input supply airflow is 35,000 CFM. And the size of the AHU cabinet is 183/84/8. 183, 183, 183, 84, and 8. Right click on next. Number of people is 20, and we just put number of people per airflow per person. 20 people. Wait. Source of. Okay, just put 20 CFM per person. Right, percentage of supply, pressurization method. If you do not use any, then just let it be 0. Click on next. User defined airflow for cooling season. Just now we put supply airflow is 35,000 here. Yeah. Okay, so it will be automatically calculated because it's in gray mode, gray box here. And percentage of supply 0. It's 100%. Okay, that's why if you put 100%, then 35,000 CFM will appear here as you set before. So click on next. User defined airflow. Yeah, you can put it again. 35,000 CFM. Right, so I do not include exhaust fans, etc. Right, we do not have exhaust fan, right? If you have, then you should click on it, exhaust fan. So just click. Right, so the rest I will just leave. I will just leave it as per default. Okay, just now we use water cooled chiller and cooling tower. Water cooled chiller and cooling tower. Okay, just set it here. So click on next. Sorry, back. And the unit. Right, so this is water cooled chiller type. So if you have centrifugal, put centrifugal. If you have screw, then put screw in the box. Okay, we use water. Entering temperature is 52. So temperature change, we just leave it as it is, around 10 degrees Fahrenheit. And we do not use economizer. Cooling tower, This is the questions for cooling tower. Okay, here we choose open circuit counterflow centrifugal fan. Since we have only one cooling tower, then the load portion is 100%. Fluid type is water, and leaving temperature from the cooling tower is 80 degree Fahrenheit. Okay, this is the questions for pump. You can see it here, pump configurations. I just leave the default setting because it is not specified in the slides. Okay, number of pumps, just put 1 because we have only one cooling tower. Okay, condenser settings. Okay, this is for expansion tank. If you have one, then put 1. If not, then don't. If you have more, according to your design. All right, so tank high efficiency for air and also dirt. This is the air separator settings. Okay, click on finish. Now you have your air handler and also your airflow diagram and also your hydronic diagram. Of course, you will have two. One is for heating and one is for cooling. All right, but you can see here for cooling, everything is 0 because we do not include heating just now, which means heating load is 0. Sorry, I think I'm gonna use the hand now. Okay, so here we can see that we actually have load for chiller because we use cooling only just now, right? So this is if you use Wizard. So you really have to know what type to use, what CFM will be used, and so on. All the questions need to be answered. All right. So just save the project. Please save it on your computer. I don't know how. Maybe you can save on this computer first, on the lab PC first, and then send to an email or put in OneDrive or anything. And then please delete back all your work on the desktop. All right. So I'm just gonna save this one. Project AHU Wizard. So by using Wizard. Okay. Save. Okay. So let's get back to our presentations. Right. So the settings we have went through all the settings, and this is the result that we have just now in the HVAC solution software. So I just snap it and put it in the slideshow. Right. So both for chiller we have loading about, how much is this? 1 million BTU per hour. And for boiler, we don't have any. For boiler, 0. Okay, I should hide this. Okay, for boiler, we have this, 0. This one is terminal unit. Okay, now we come to rooftop units. Um, what is actually the difference between air handler unit and rooftop units? It's actually the location. Basically, all the components is almost the same, or maybe the same. It's very similar between air handler and also the rooftop units. The difference is only the rooftop units is located on the roof. Okay, and there's also two ways to design rooftop unit from HVAC solution. And of course, first by using rooftop units icon, and second one is the same as a issue by using wizard. Right. So we have here louver, fan, outside fan, then cooling coil, and then filter. So this is basically the components in rooftop units. And how to do it is just the same. Okay, I'm just gonna show you where it is located. I mean the RTO icon. Okay, but I'm not gonna show you how to do it because basically it's the same. Okay, rooftop icon here, rooftop icon tab. And here we have rooftop cabinet, rooftop plenum. And if you want to use wizard, just click on wizard. We have rooftop unit wizard. And of course, you have to answer the question that is asked. So that is the software knows what are the input, user input. All right. Okay. This is if you want to design the rooftop unit from HVAC solution. Just go to File, New, Display Grid. Just the same. Just follow the steps that is the same as for the steps for a handler unit. Right? You can try it later. Right. So maybe I will show you how to use Wizard. It's just a few steps. Okay, by using Wizard, just go to File, New, and click on the Wizard icon, Rooftop Unit Wizard, and then the system is number of system is 1, detail level is system. Next, okay, just do it first. Okay, click on New since you are already here. So click on File, New. Right now we have this. Click on Wizard. Okay, you can see there's several wizards. Now we have Rooftop Unit Wizard, the second one from the left. Okay, click on it and choose number of system is 1, detail level, system. Click on Next. Right, next is select the usage either for cooling or heating or both. And for this case, we choose heating and cooling. And select the type of fan. We use here blow-through fan brand from Twin City. We use belt-driven forward curve centrifugal double width. Right. So just follow the steps. ID you can put 1 if you want. And of course for rooftop unit. And then heating and cooling. Click on Next. Do not include terminal. No. Okay, we use blow-through fan, quantity 1, Twin City, belt-driven forward curve centrifugal double width. Yeah. Click on Next. Right. Basically, you would have to know what are the requirements or the specification for your system. Of course, you would need to know that first before you can design in the software. Software is just a tool, so all the inputs are from you, and you really have to understand what you are doing and what you are choosing. Right? So include pre-filter. We use MUF 8, cartridge, flat. Right? Do not include final filter. And ID. You can put ID any location. Yeah, you can write your location, Malacca, for example. And supply airflow. This is the most important one. How much CFM would we use? For example, for heating season, we use different CFM, 1000 here. And for cooling season, we use 2000 CFM. Let's go back to the software. Okay, I'll just exclude the relief fan. And next, okay, so we use pre-filter, MUF 8, right? It's MUF 8, yeah. So cartridge, and do not include final filter, do not take that one. Click on next. Right, I will not include soundtrack. What's the space? Okay, the space setting. So for heating coil medium, I will use hydronic because I want to use boiler. And cooling coil medium, can also use hydronic because I want to use chiller. Next, yeah, for space, just put 1. Yeah, you can put Malacca. The settings here is 1000 CFM for heating season and 2000 CFM for cooling season. Right? Okay. So next, number of people is 15 and 20 CFM per person. And click on next. Length with height is if you know, I mean the dimension of space, of course you have to know. Okay, let me see. Okay, I just put 8 times 8 times 8. Right. So click on next. How many CFM again? Okay, 15. 15 15 people and 20 CFM per person. Click on next. Right, so because we already put airflow before, or maybe you can put it again. For heating season, 1000. Right. Okay, click on next. This is hydronic options. I will just leave as default. Heating source boiler, cooling source chiller. Click on next. Okay, for boiler, this is the settings for boiler. I will use water. And this is the settings for air cooled chiller. I will use water also. And this is for pump. I'll just leave the default settings because I do not have specific requirements now. Secondary pump, manifold primary pump. Okay, expansion tank. I just leave S1. For air separator, also I use high efficiency for air inlet. Click on finish. Now you have your rooftop, your airflow diagram, your hydronic heating hydronic diagram, and also cooling hydronic diagram. Right, so now if you can see, I'll do it bigger. I'll zoom it. Okay, for cooling, we have load 73,000 BTU per hour with 12.1 gallon per minute of water. And for heating, I have 88,400 BTU per hour with 4.5 gallon per minute. All right. So, and supply fan during heating season, as we said, is 1000 CFM, and for cooling season is 2000 CFM with static pressure about 2 to 2.13 inch water gauge for those seasons. All right. So the settings, you can still change it actually by clicking on the space, and you can see here on the left side, you can change the load, heating, the space, air conditions. You can change the types of, for example, the types of fan. You can still change it, no harm. Just go to key data. You can change the airflow portion type. You can change the fan type. What I mean is, it doesn't mean that if you use Wizard, then everything is fixed. No, it isn't. So you can still, after you put all the inputs, and if suddenly you have any change during the design stage, you can still change the components by clicking on the components, double clicking on the components, and change whatever needed, types, and also all the inputs. No harm done. Right? Okay, these are the results by using the wizard. Okay, here it is said that you can put additional supply grill instead of one by clicking space icon supply. Click on, in this case, it used lab as space. Then copy the grill and paste. Right? Okay, we can do it just. Here it appears as one because I set it as one. If you write laboratory, then laboratory will appear here. Right, so you can add more supply grills just by clicking on the space, then go to supply. Okay, this one is supply, right? Okay, just go over it and supply appears. So go to grill, we just put linear, just put it here, right? So you can put more. If you have the same grill, just copy and right click and paste into the space, right? So just copy again. Let's say I want to put 3 supply, the same supply grill. Okay, so just connect it Don't forget. Sorry. Okay. This one more. Something wrong. You can arrange it better after this. Right, so this is the examples of how to add more grills in a space. All right. So next is air-cooled chiller. Just to recap, air-cooled chiller is a central source of piece of equipment that generating chill fluid, and of course it extracts heat from the fluid and rejects via fans, as the name goes, air-cooled chiller. So via fans, via air, and the chiller also needs a internal refrigerant compression or expansion cycle to generate the cooling, and employing condenser and evaporator. And according to the used type of compressor, the cool chiller, there goes the air cooled chiller types. I mean, the name or the types of the air cooled chiller is according to the compressor that is used. For example, reciprocating, screw, rotary, scroll, etc. And of course, its condenser is to reject heat, and the evap is to produce a chill fluid, for example, water. And it is to be noted again that the chiller capacity will be noted in tons of refrigeration, and one ton is equals to 12,000 BTU per hour, or equals to 3.5 kilowatt. Right, so how to build air-cooled chiller? So again, the steps are exactly the same as rooftop unit. The difference is there are extra questions as below, which is what is a air handler or rooftop unit source? You have to choose air-cooled chiller, and the fluid type of the air-cooled chiller. You can choose from the drop-down list here, and I choose water. And the results are as follows. So this is the schematic diagram for air-cooled chiller. We have filter, right? So we have outside fan, we have cooling coil, and we have here ST. Right, just go back to the software and just go new and click on wizard. We have here right, for air-cooled chiller, just use Rooftop Wizard, and the settings are all the same except for the one that we discussed just now. This is the last setting, because every time you do a project, the last settings that you use on that computer will be remained, and so that you do not need to change anything. Okay, this is the difference. The source and air cooled chiller, we use water. So the source is air cooled chiller, right? And oh, go back. I forgot to change that. We just use for cooling only, right? Until you go to source, air cooled chiller, and then here we use water, right? So everything else is just the same. All right, so the results is as follows. The difference here is only I included the sound trap. ST stands for sound trap. So that's all. So I hope you can follow the tutorial and the lecture, and you can try yourself later by using HVAC solution software. Thank you and good luck. See you in the next video. Thank you.